Hello, everybody. Apologies for the slight delay in getting myself set up. I hope you can all see my slide and my screen. Thank you. And yeah, so thanks a lot, Giorgio, for the great presentation. First, I think it's going to help me in introducing some of the context that I want to introduce here. So I would like to talk a tiny bit from a different point of view of how AI can be used for archives and collection, especially for born digital archives and collection. And I'll do that through a number of examples. And while I'm in warnings, you might be interested to know that the picture in this title slide has absolutely nothing to do with the presentation. So just to give a tiny bit of context, I come from a background which is a bit different and in terms of AI, which is what some people might refer to as good old-fashioned AI, and which can be best described as not at all machine learning. The idea of good old-fashioned AI or symbolic AI is that we can achieve some form of intelligent processing of data and some form of, say, knowledge understanding and meaning in computer science through explicit representation of knowledge through an explicit inference. And what that really means, if I reuse Giorgio's example, is that instead of showing to a machine learning method a lot of examples of tigers, and every time pointing, saying, this is a tiger, and a lot of examples of not tigers, and saying, this is not a tiger, what this symbolic AI approaches used to do is basically encode the rules that enable us to decide that something is or not a tiger. So it's about encoding the knowledge, it's about representing explicitly knowledge about an area, so that once this knowledge is encoded in a way which is processable by the machine, we can make explicit inference about it. We can apply those rules and understand and kind of derive interesting new information from that knowledge which is encoded. Now, obviously, there are a number of advantages in doing this. Some of them are that it is fundamentally explainable. It's much easier to explain why a conclusion has been achieved by pointing to the rules that were followed to achieve this, to arrive at this conclusion, than to explain that it all comes from a complex mathematical model with a lot of data. But it also has a lot of disadvantages, including that somebody has to sit down and write those rules, and somebody has to spend a lot of time figuring out what they mean. So in this presentation, what I would like to do is show how, say, this method, which is, again, seen as the good old-fashioned way, is coming back in combination with data mining, machine learning, and natural language processing, so that this combination can address both the scaling issue, but also use AI to generate knowledge which is actually processable, understandable, and interpretable, and help in understanding, exploring, and exploiting the content of large collections. So I say I'm going to do that through a number of examples of projects in which I've been involved. Some of them simple, some of them a bit more complicated, that I've applied these notions to look at different aspects and for different kinds of collections. I have to, again, give a disclaimer that I'm a computer scientist. So most of the domains I'm talking about, I am completely ignorant in, and which puts me in an advantage that I can then learn about a lot of domains whenever I get into a new project on any of those domains. The first example I wanted to show is the one of the LEDA project, which is a project from the Open University where I used to work, which is about creating an online database, and which we can call a knowledge base of paintings representing hell, sinners, and punishments from churches in Crete. Now, what I find interesting with this project is that when it first started, I really thought it was relatively simple. It was about putting a tiny database of things from 92 churches online and representing it, so that people could access the data. The reality of that project, which took much more time than I expected it to do originally, is that it is actually quite complicated, because the objective of having such a database is to represent the kind of implicit rules that exist in iconography and that are represented in this particular context, and to enable looking at this collection of what turns out to be several thousand pictures of paintings in churches, to make it available in a way where we can query this kind of tacit knowledge underlying tacit iconographic knowledge, and so that we can query it to better understand, what those representations meant, how they were established, and what were the codes that are related to them, and how to understand them in the context where they were set. So I'm going to not spend a lot of time on each project, but basically what we ended up doing is a very large, say, a reasonably large knowledge graph that enables navigating through churches, through paintings, and through representations across the whole database, in a way that we can focus on a lot of different points of view, from geographical to the figures and scenes that were represented. You can look at this collection from looking at a specific aspect, or even a specific kind of scene or punishment represented in the paintings. Or you can look at it from a particular kind of geographical context, or from the context of what connects with geography with certain elements of culture and certain elements of, and what it related in terms of representation, which at this point, in a sense, this is kind of my simpler project, for the reason that what it ended up doing is really putting this kind of knowledge-based representation of the metadata for each of the paintings that were collected and photographed, so that we can achieve complex queries on those paintings and on those metadata, as a way to infer interesting elements about what they say, what the entire collection say, what it says as a collection. But it still looked mostly entirely at the metadata. It didn't look at the content of the painting beyond what was annotated by the members of the project as representing particular figures or particular scenes. And so the next project I want to talk about is one where this is exactly what it did more specifically. This is a project led by a PhD student in NUI Galway. She's a PhD student in English literature, and what she's doing is analyzing text from early women philosophers. And the idea she had was to try to represent what those texts actually say in terms of an ontology, and to try to really provide a structure for those texts, especially considering that those texts, the texts she's considering, are correspondences between several philosophers around specific, say, moral and philosophical questions. So what we ended up doing here is creating an ontology that can represent arguments and propositions in those texts, and how those arguments and propositions relate to the particular philosophical concepts and the topics that the texts are dealing with. So to have, in the same way as we would have the representation about the metadata of the text, or in the previous project of the painting, a knowledge graph, a structure of the content or of those texts in a way which is queryable as a knowledge base. To achieve that, we developed a specific tool enabling to identify arguments within the text and to connect those arguments with each other in a knowledge graph to understand how arguments are, say, supporting or contradicting each other, how arguments are supporting or contradicting specific propositions, and how arguments are being reused across several texts, especially when those texts are responses to previous ones, so that these create a pretty large knowledge graph from which the whole kind of train of reasoning that those texts represent can be followed and can be queried. And all of those are directly connected to information about to automatically extracted topics within the text that represent philosophical concepts and that are themselves connected to a range of other resources. So it is using the analysis of the content of the text to also connect what they say and what the collection of those texts represent with other areas and other collections and other resources. And that idea of looking into the content of the collection to connect to other sources of knowledge is also a key part of the project called the Listening Experience Database. Again, another project from the Open University in the UK, where here what we were doing is trying to create a large resource, again, calling it a database, but in my view, it would be more appropriate to call it a knowledge base that represents accounts of people listening to music across history. So what the project did is collect thousands of, say, extract of text from publications or correspondences that describe somebody listening to music. And what the entire project did is create, again, a large knowledge graph representing those listening experiences, representing the context in which they were happening, the performance of the music, the details of the music, and the details of the sources of the accounts, whether they are publications or correspondences or other different aspects. What's really nice about doing this way is that obviously the music, performances, the accounts, the sources can all be connected again to a number of other sources. So for example, we were connecting the publications from which the accounts were found to the knowledge graph of the British Library, or we were connecting the locations of the performances and the accounts with knowledge graph representing locations across the world that could be connected to other aspects. We were connecting the people listening or the people writing the publication or the people performing the music with other knowledge graph where we could have a broader access to their work, to what other things they might have done, and that could connect us potentially to a range of other listening experiences to populate the online knowledge base. So you can see here some part of the interface of the project and of the access to the knowledge base, where all those features of connecting the kind of core data that is represented in the collection with external data enables a more intelligent and a smarter way of interrogating those, making us able to query and explore this collection in a way that that again relates to other things and therefore gives us a richer access and a richer use of this database. Interestingly, a bit like the previous project, a follow-up from this project and something kind of directly feeding into it is the idea of analyzing the content again of the collection, looking at the text in the collection, and here bringing data mining and machine learning methods so that from the thousands of examples of accounts of listening experiences we had collected, we could identify other ones in other sources, and building this tool that can tell you that can go basically in other collections to find automatically accounts of listening experiences to bring into the database. So that's a very interesting aspect, especially in the music context. And say that also brought the idea that, you know, it's nice to analyze the content of text describing listening to music. There is an element that this project didn't look at, which is the analysis of the music itself and how music connects to cultural context and to socio-economic context and all sort of different aspects like this. So that brings me to the last project I want to describe, which is one where there is not a lot of result currently because it just started in January. This is a European project with the Open University, NUI Galway, the University of Bologna, and a number of other partners, where the objective is to use data mining and machine learning approaches to analyze the content of music in order to extract patterns, rules, structures in music that we can then connect with each other and connect with the context. In short, what we are trying to do is trying to understand how the evolution of music, the variation of music in a lot of different musical traditions are influenced and influence themselves the historical, cultural, and economical context in the context in which they appear. And there is a lot to do in that area. I'm especially myself looking at repositories of Irish traditional music, where we know that music is a big part of the culture in Ireland and also is strongly influenced by geography, by cultural and historical events, and by a lot of different aspects, and has been influenced by a lot of other elements. And for example, we are going to work on connecting what we find in Irish traditional music with what can be found, for example, in Scottish music or in Dutch music or in French music, and knowing that we are expecting to find where influences have happened and to relate them to specific events and specific eras. So we do still have some initial results from this project where we can start extracting from Irish traditional music specific rhythmic and melodic patterns that happen in different genres, and being able to compare how those patterns kind of exist or not and are reproduced in different genres, but also in other traditions. And one of the side effects of doing this, making those collections more accessible and more understandable, is using those patterns that we find in collections of Irish traditional music as building blocks for creating new music. And I put here an example of a small project we did at the end of last year with a musician called Danny Diamond, where we extracting building blocks in terms of sequences of notes from collections of Irish traditional tunes, in order to reuse those to create a new, a tune, an Irish jig that follows the data follows weather data from a storm that happened 2 years ago. And that means creating new content that shows the richness and what exists within a large collection by using both the kind of machine learning based AI techniques and those more explicit representation in symbolic AI. So I'm probably out of time now. This picture also has nothing to do with the conclusion, but I just wanted to kind of, through this presentation, raise this idea that AI techniques traditionally has been used for archiving collections. Those AI techniques have been traditionally those symbolic methods. And we have been moving, when wanting to analyze the content of collections and archives, to the machine learning and data mining approaches that are very efficient and can scale much better but that are also, as has been argued in previous presentations, can also lead to a lot of issues, especially with respect to interpretability. So I do believe that the next step in AI for archives and collections is a one where we can combine those two AI traditions into something which is both scalable, can analyze content, and can be interpretable. Thanks a lot. I hope I didn't take too much time, and I will straight away pass the mic to Bran.